All right, great being here. Thank you for the introduction. So, as with some other companies like Inferior, for instance, we are also a spin-out of Chalmers University of Technology. We spun out in 2019, and I'm Simon, the CEO and co-founder of the company. With Retein, we've set out to recover waterborne resources with our molecular precision filters, like these. And I'll get back to what they actually do a bit later. But first, why do we want to do this at all? Well, because today we are wasting a lot of resources in terms of wastewaters. They're called wastewaters because they are usually costly and they go to waste. Actually, 380 billion cubic meters of wastewater is generated each year from industries, municipalities, and so on. And that's enough to cover the entire Germany in 1 meter of wastewater, which is, yeah, it's not the nicest picture to put in your head, perhaps. But if you look at from the flip side of things, then these wastewaters are actually full of resources. It's just that they're a complex mixture of them, which makes them difficult to handle. These resources can be anything from, as you see here, metals, nutrients, and of course the clean water itself, as we like to really value as well, even though the monetary value is questionable in some instances, even today. But the thing is that these resources can be recovered by the right kind of technology, specifically separation technology. Separation processes are found across all industries, basically, and especially in manufacturing of, for instance, concentrating juices and also manufacturing of pharmaceuticals, the active pharmaceutical ingredients, and of course in wastewater treatment from all kinds of industries. They usually don't take center stage, I guess. They're sort of behind the curtains in a lot of processes. But they actually account for more than 1/10 of the total global energy consumption, which is quite a massive amount of energy going into these processes. And that's partly because they are both blunt, they're inefficient, and they're also costly to run in many instances. This is, to some extent, partly why circular resource use hasn't really taken off yet, I would say. So as you can see here, we have a comparison of extractive material production, for instance, and some examples of growing, but still very small circular resource use environments. And there is a huge gap there, as you can see, billions to trillions is quite a significant amount of dollars going in between there. So the right separation solution that's actually needed to accommodate these problems and to go more circular in terms of the broader picture is these separation solutions that have a molecular precision and high selectivity, as you can see on the highlighted column on the left. This is something that we're looking to uniquely offer as of today with Retein and with these kinds of filters. And we're uniquely offering them in the combination with this continuous processing, which is key for the operators, for the actual plants in running these things, because then they can minimize the downtime that comes from batch-wise processing and so on. How we're approaching this then is to use biomimicry. So we are mimicking how the cell membrane actually does transportation of resources in and out of the cell. So all the resources that it needs, nutrients, metals again, water. We are, as you can see, we're using the membrane proteins then that are these gates for these resources, and we're using them as fast tracks across the filter that we're developing, which is otherwise a very dense barrier that's rejecting a lot of different species, which I'll get to soon. And with the help of these proteins, then we're targeting close to 100% selectivity, which is unique in its own way, but also 200 times energy efficiency compared to the technologies out there today, like reverse osmosis desalination membranes, for instance, as one comparable there. To go a bit into more detail on what we're actually doing in our operations when we're producing these filters, we are growing yeast cells. We're extracting the aquaporin protein from them to be able to then stabilize them uniquely. So So we're looking at stabilization using the same approach as diatoms, these silicate algae in the oceans. So we're using biomimicry for that portion as well. And this is something we patented in the US, Australia, Sweden, Singapore so far, in order to be able to actually leverage these proteins, which are otherwise very sensitive and unstable outside their native cell membrane environment. So what we're doing is that we're producing these powders. These powders are used as additives in the conventional kind of filter setup, where you have a polymeric membrane, very dense polymer that acts as a barrier. And again, our capsules then with the proteins inside can act as the fast track for the resource of choice, which is, as a starting point, water from our perspective. And then we can go into wrapping these membranes into these modules, which we're doing with partners in South Korea, for instance, for this specific one, but also in Germany as of late. So we are looking to become a module provider, so selling these kinds of filter modules, but also we can add functionality to existing membrane manufacturers' lineups in order for them to expand into other sectors that they haven't been able to go before by providing our stabilized protein additives as an additive, basically. The current focus that we have, as I mentioned previous as well, is wastewaters and extracting water out of wastewater in order to minimize the wastewater volumes, because that's what's costly to a lot of the clients that we're working with today. We're still on the piloting stage, as of today, I should say as well. But we're looking at complex wastewaters where you typically have small organic molecules, could be pharmaceutical residues, could be urea, for instance, a toxin that's very similar to water in size and characteristics, but also PFAS, which is a hot topic that's rising on the political agenda as well. We are looking then to concentrate the wastewaters in order to save cost for our clients, and we're looking to do that in areas such as biomanufacturing, which includes pharmaceutical manufacturing, also recycling, and going to medical devices in wearable dialysis and aquaculture. So we're still exploring quite a bit. We're in that stage where we can use the same functionality and technology to try our benefits in a lot of different, or at least a handful of different application areas. So one proof of concept we've done then is within aquaculture and wearable dialysis, looking at the urea removal. There we're seeing unprecedented 90% rejection rate of urea while retrieving the water then. And also doing that at a very energy efficient, not yet 200 times as energy efficient as comparable technology, but at least 2.5x, which is already significant OpEx savings coming through there. So with that, this is sort of the stages we are projecting that we'll go through in the following years. So currently then focusing on wastewater minimization in order to get a business going in that direction. Then, since we are recovering the water, highly pure water, we're looking to recirculate that back with the clients into their manufacturing processes to allow them to have access to water and to save costs on input resources as well. And then the third stage there is to go to the platform technology where we can use different proteins. We're looking at a lithium channel, for instance, to recover the lithium from battery recycling processes. So we can look at operating more or less like the cell does, different proteins for different resources and transporting them, recovering them, designed by what proteins are in the membrane. We are a venture capital backed company. We recently started our fundraise for our upcoming round, so we're looking to close that sometime December this year. We have raised about 1 million euros in equity so far, and complemented that with about roughly the same amount of non-dilutive funding, which we've been successful in. And we're looking at something around 3 to 5 million euros for this round size. Not necessarily only equity, but could also be the non-dilutive funding that we're applying for fairly frequently as well. But we're looking to, with this funding, basically to get us all the way up to the brink of commercialization, which will happen in 2027 in the first application area. So we're looking to finalize pilot projects, and we're looking to scale our production capacity to some extent, but also to leverage contract manufacturers on the filter side to be able to scale those aspects according to the demand from the clients we have. So yeah, I'm here basically to discuss and look for investors with relevant networks primarily, to add to our already existing lineup of investors, including Industrifonden, Navigar Ventures, Chalmers Ventures, Butterfly Ventures, and Catapult Ocean. So with that, happy to discuss after this or now, and thank you for your attention.
Thank you very much, Simon, and please raise your hand if you have any questions to Simon. Otherwise, I will start off. In 2 years, there will be commercialization. And what kind of end users are you looking for when it comes to commercialize your project?
Yeah, exactly. So we have a couple of them lined up in different projects that we're running now, and we think that the first ones will be the recycling actors, since they are handling a lot of different streams that are of extra complexity to their clients then. So looking at those kinds of actors is probably where we'll go first in terms of commercialization. We see a clear sort of regulatory pathway there as well.
Okay, so it will not be like producers of like Lonza or Fujifilm or providers of pharmaceuticals, so to say.
Yeah, those actors are in there as well, but
okay.
yeah, but primarily I think going for the focusing on the wastewater side of things is the key, and then when we're looking to circulate things back into the process, which we're looking to do in all these aspects as well, then we're entering more regulatory sort of challenges in terms of pharmaceuticals and so on.
Okay. Do you have any plans to go public?
Well, I mean, we have plans, but not necessarily going public. Perhaps we're also sort of setting up the company to be a good company, a self-sustained company in that sense. But to maybe become an acquisition target as well for bigger membrane manufacturers, for instance, that are now and then acquiring capacity to go into other areas where they can't go today, basically. So could be, but in some time from now.
Yeah, and you were talking about patent. You had a number of patents. For how long are you covered, so to say?
So 2019 is the priority date on the first one, at least there. So for 20 years until 2039, then I guess is the starting point.
Yeah, and this next steps up to commercialization. What kind of challenges do you see in this next step for the company?
Yes, it's finding the right partners, which is part of why we're looking to expand our network, industrial network, not the least, to be able to grow with other actors. We're looking to approach this in a fairly capex light way, so we don't build all the manufacturing in-house, for instance, even though that's something we want to do and bring in-house with time. But that's one key aspect, of course. And then we have some not necessarily the near term sort of. But the regulatory aspects are always interesting as well, especially when you're looking at reusing resources and putting them back into some kind of production.
Yeah, I understand. And where are your end markets going forward? Is that in Europe, or is it globally initially, or could you elaborate a little bit about that?
So it depends a bit. So with our clients in wearable dialysis, for instance, they're targeting the US as their first market. Whereas pharma-wise, it's very more local in that sense, so Europe-based, for instance. So it depends a bit.
Yeah, time will tell.
Yeah,
right?
exactly.
Okay, Simon, thank you very much for coming. We have to move on.
Thank you very much.
Yeah.